Today I'm gonna talk about the derivative of composite function, the application of two chain rules. Here we're gonna focus on the trig function and logarithmic function. Now let's take a look at the following formulas. The first formula is a typical chain rule. Here the capital F can be any trig function. Okay, can be any trig functions. So if capital F is sine, then the derivative of capital F gonna be cosine. If capital F is cosine, then the derivative of capital F gonna be a negative sine. If capital F is tangent, then the derivative of capital F gonna be secant square. And the second formula is the derivative of composite logarithmic function. The derivative of ln fx equals 1 over fx times the derivative of fx. The third one is the power rule. And the fourth one is the constant multiple rule. And I also list the derivative for three trig functions. Now let's take a look at the first example. Now let's compare the first example with the formula 2. As we can see, the little fx can be written as sine 2x. Okay, so we write down the fx equals sine 2x. Now we're gonna apply the formula 2. We're gonna have 1 over fx. So since the fx is sine 2x, so we're gonna have 1 over sine 2x times the derivative of fx. So we have sine 2x prime. Okay, now we're gonna address the derivative of sine 2x. We can apply the chain rule for this guy. And what is the capital F? Capital F is sine. What is the little fx? That is 2x. We can write down the little fx is 2x. Okay, now we can simplify it. 1 over sine 2x times the derivative of capital F. Here is derivative of sine, gonna be cosine. And what is the fx is 2x times the derivative of fx. Here is 2x, so it should be a derivative of 2x. Now let's take a look at this term. This term we can apply the constant multiple rule. Here we have constant 2, so that means we can pull this constant out of derivative. Okay, we can pull the 2 out of the derivative. We're gonna have the derivative of x. Okay, derivative of x equals 1. Okay, very good. Now we can write down the answer. So 2 times 1 is 2. So we can have 2 here. Cosine 2x divided by sine 2x. And as we know, follow the trig function relationship, we know the cosine 2x over sine 2x gonna be cotangent 2x. Okay, now let's take a look at the second example. We're gonna follow the same strategy. Here we have ln 2 cosine 3x plus x squared, the first step we need figure out what is fx. Fx is here. Okay, so we can write the fx equals 2 cosine 3x plus x squared. And now we're gonna apply this formula. We're gonna have 1 over fx. Fx is 2 cosine 3x plus x squared times the derivative of fx. So we have 2 cosine 3x plus x squared. And now we can simplify it. We have 1 over 2 cosine 3x plus x squared. And here the derivative of sum of two functions, that means we're going to do the derivative for each function. So we're going to do the derivative for each function. Okay, now let's take a look at the first function. For this function, we have 2 times cosine 3x. 2 is constant. That means we can apply the constant multiple rule. So we can write down as 2 cosine 3x prime. Okay, and for the second term, we can apply the power rule. We have 2x to the power 2 minus 1. Now we can simplify it. We have 2 cosine 3x plus x squared 2 times cosine 3x prime plus 2x. Okay, now let's focus on the derivative of cosine 3x. How to do the derivative of cosine 3x, and we're gonna apply the Trig rule. Here the capital F is cosine. Okay, and what is the little fx? That is 3x. Okay, 3x. Now let's simplify it. 1 over 2 cosine 3x plus x squared. We have 2 times, here's derivative of capital F. Here's derivative of cosine, gonna be a negative sign. Fx is 3x times the derivative of 3x. Okay, and plus 2x. Okay, now let's take a look the this term 3x prime. How to simplify this guy? As we can see that 3x is we can apply the what? We can apply the constant multiple rule, right? So basically we can write this guy as 3 times x prime. Okay, and the x prime is 1 prime. So gonna be 3 times 1. Okay, 3 times 1, and 3 times 1 is 3. 3 times 2 is 6. Here's a negative, negative 6. So we have 1 over 2 cosine 3x plus x squared times negative 6 sine 3x plus 2x. Okay, so that's the answer. Now let's take a look at the last example. For the last example, we're gonna follow the same strategy. The first thing we're gonna figure out what is fx. That is tangent pi x squared plus 3x. Fx equals tangent pi x squared plus 3x. Okay. Now let's follow this formula. We're gonna have 1 over fx. So we have 1 over tangent pi x squared plus 3x times the derivative of fx. So we have tangent pi x squared plus 3x prime. Okay, and now how to do the derivative of this guy? We can apply the Trig rule. The capital F is tangent. What is the little fx? That is pi x squared plus 3x. So we can write down fx equals pi x squared plus 3x. Okay, now we can simplify it. 1 over tangent pi x squared plus 3x. And the derivative of tangent gonna be a secant square. Okay, and fx is pi x squared plus 3x times the derivative of fx. So we have pi x squared plus 3x prime. Now let's take a look at the second term here. The derivative of the sum of two functions gonna be the derivative of each function. Okay, so we can write down the derivative for each function, and then for the first two terms we can copy it. Tangent pi x squared plus 3x, and then we have pi x squared prime plus 3x prime. Okay, and for the first function we can apply the constant multiple rule. We're gonna have pi times the derivative of x squared, and for the second function very similar, 3 times x prime. So we have secant square pi x squared plus 3x divided by tangent pi x squared plus 3x. And for this time we're gonna apply the power rule. So pi times 2x, 2 minus 1, and for this term, the derivative of x is 1. 3 times 1 is 3. So we're gonna get the answer would be secant square pi x square plus 3x times 2 pi x plus 3 divided by tangent pi x square plus 3x. That's it.